Hello, everyone. Thanks so much for coming to this talk on Data Flywheels. So there's a lot of interesting content, or I hope it's interesting. I think it's interesting. I'll let you be the judge, though, about Data Flywheels that I'm looking forward to covering with you in the next 20 minutes. Before I dive into that directly, though, let me just introduce myself. So my name is Yali. I'm a co-founder and CTO at Snowplow. So I'm a data guy. I've worked in data all my life. Data is kind of my passion. And I was one of the co-founders of Snowplow, which was born as an open source project back in 2012. And for those that don't know, Snowplow is customer data infrastructure. So companies use our technology to create rich proprietary first-party data that describes what their customers are doing on different digital platforms second by second and minute by minute. As a data guy, that's a data set that I'm particularly passionate about, because we can really use it to understand in a lot of depth the decisions that people make, but also how they make those decisions and the environmental factors and other factors that drive those decision making. So that data is rocket fuel for a whole host of AI applications. Probably the most common are things like personalization and recommendation, but there's also digital analytics and attribution and next best action and all dynamic pricing, and a lot of other applications can be built on top of that data. And we're very lucky. We've got thousands of open source users globally and more than 250 commercial customers. So that's hopefully a little bit helpful so you understand who I am and the context that I come from when I think about and talk about Data Flywheels. I was very lucky. Earlier this year, I got to attend both the Snowflake and Databricks summits in San Francisco. And Jensen Huang from NVIDIA keynoted at both those conferences. And at both of them, he talked extensively about data flywheels. Before that, I hadn't really heard about the concept of a data flywheel. And that was super interesting. And I found it a very useful frame on what I saw a lot of organizations were doing in AI. And that's why I've chosen to focus this talk on data flywheels. I mean, it's you listen to him, and I don't know how many of you have listened to either of the talks that Jensen Huang gave, but they're both on YouTube, and he literally can't stop talking about data flywheels. And I sifted through the transcripts of both of his talks to try and find the best quote that really crystallized what this data flywheel concept was that he was talking about endlessly. And it was hard to find exactly the right quote, but this is the closest that I got. And it's about him talking about the data flywheel in the context of kind of an AI agent chatbot. And the thing he says is the important thing about the chatbot, the customer service, it's partly the fact that you can automate. It's great that you can, have a machine go and give customer service versus a person. The thing that really excited him is it's mostly about the data flywheel. You want to capture the conversation. You want to capture the engagement in the data flywheel. It's going to create more data, and we're going to talk a little bit about how it creates more data, of course. And we're probably seeing data expanding growing about 10 times every 5 years. Wow. So what's he talking about, and why does it matter? More importantly, how does the data flywheel work? Well, if we start with a support agent example, and probably the best, or probably the most famous example of a customer that's implemented a company that's implemented a support agent is Klarna. They were very, very early to leverage LLMs. I think they used OpenAI in particular to build an agentic application that replaced 700 of their customer support agents. So they built this this support agent application that speaks more than 35 languages, resolves customer issues faster than the human beings it replaced, sort of 2 minutes versus 11, which is extraordinary, and does that with the same level of customer satisfaction, and save them, the amount they quoted was $40 million a year, so very, very significant saving. What's going on behind the scenes, and why is this a data flywheel? Well, it starts with proprietary data. In order to train the application to give the different people that are asking questions to the support agent the right answers, the team at Klarna will have had to feed that support agent a huge amount of proprietary data all about the Klarna service, all the documentation, but also data about all the different chats and support conversations that their human agents had with their customers, so that the agent could understand the range of questions that were answered and what made a good answer and good support behavior, and what made less good support behavior. So all that proprietary data, and it's proprietary because only Klarna have the relevant data to help a Klarna-based support agent support their customers, feed this agentic application. The AI agent then uses all that data to go and give new customers answers to their questions. And it does that, and assuming it does a good job, and looks like it does, they get improved customer loyalty. Customers are getting answers to their questions faster. They're getting their tickets resolved quicker than they were when they were talking to humans. And they're reducing their costs, which is wonderful. But the interesting thing, and what makes this a flywheel, is as this application runs, more proprietary data is developed. Because now every time the agent is having a conversation with a customer that needs some help, you've got a new chat log. There's a new conversation. And the agent answers the question, tries to resolve the customer's query, and then it learns whether it's successful or not. And so the proprietary data that's generated grows. As the agent has more and more conversations, the amount of proprietary data grows and grows. That proprietary data is then fed back into the agent that drives improved agent performance. The agent then talks to more and more customers, gives them better and better service, and outputs more and more proprietary data that goes back in. So there's this positive feedback loop. That's why it's a flywheel. And that's why Jensen in the previous slide really, all the way back here, really emphasizes this fact. You want to capture engagement in your data flywheel. It's going to create more data. The agent creates the proprietary data that then feeds the AI to output better results, which then creates more proprietary data, and that positive feedback loop continues. And it's easy to understand how the flywheel works in the case of the support agent. But Jensen Huang is very clear. There are these data flywheels that can be created all over the place. And he says all of us have flywheels of data. We're using it in our chip design. We're using it in our bug database. We're using it in creating new products and services. And we're using it in our supply chain. So the number of places that you can build a data flywheel is absolutely enormous. So I particularly like this example because it's so different to it's so different to the support agent example. So if you, what Jensen Huang is intimating is that NVIDIA, they're using AIs to design chips, to design GPUs. And NVIDIA have more proprietary data about GPU design than anyone else because they're the world's biggest manufacturer of GPUs. So all that data about all the different GPUs they've designed and the actual performance characteristics of them, they've got an enormous amount of that proprietary data that they can use to then feed an agentic application that's designing these chips. And as the application runs and comes up with more and more designs that the NVIDIA team can then test, more and more proprietary data is created, feeding back in, making the application better and better. The application's learning over time what makes a good and effective design for a GPU. And what that means is that it's incredibly difficult today for another company to come along and design better GPUs than NVIDIA. Certainly for another company to come along and try and use AI to design better chips than NVIDIA, because NVIDIA have more proprietary data than that newcomer. And so that newcomer's, with the best AI in the world, is going to struggle to come up with something that can design better because they just don't have the data to fuel that AI. So anywhere there's an agentic application, there's an opportunity to build a data flywheel. And anywhere there's a machine learning powered process, kind of, the more traditional machine learning that we've been doing for years and years, there's the opportunity to create a flywheel. So this is an example we see a lot in our customer base. We see a lot of our customers that have great proprietary data that describes exactly what their customers are doing across all their different digital touch points. And they use that data to understand, what kind of content and their patterns of behavior And that then can power personalization engines. And many of them have more than 100 different algorithms that are personalizing different parts of the user experience. Every time one of those personalization algorithms personalizes part of the experience, that's an opportunity to create data to understand, was that personalization successful? And that data, that proprietary data, is then fed back, making the personalization better and better over time. So again, you have this positive feedback loop, this data flywheel. And these flywheels, from a commercial perspective, they drive sustained competitive advantage, because just as the case with NVIDIA and their LLM-powered GPU design, if a competitor wants to come along, they've got to compete, if they want to build something similar, to have an equivalent proprietary data set or a better proprietary data set. But if you as an organization have built this data flywheel earlier, and if you're running it over time, you're churning out loads and loads of proprietary data that you're feeding back into it. And it's just it's very hard for a newcomer to come in and outcompete you in that application. And there's a really nice analogy for this kind of positive feedback loop from the military of all places. So there's this OODA loop model that was developed by John Boyd, a military strategist who was an airline pilot. So he flew F-86 Sabres in the Korean War. And he was puzzled why US pilots were beating their Russian counterparts in far more dogfights. Their sort of ratio of their ability to shoot down the enemy was much, much better than their Russian adversaries, even though the Russian planes were on paper technically superior. They flew faster, they could ascend faster, they could fly higher than their American counterparts. The two advantages that the US pilots had flying the Sabres were that they had better visibility. They had this kind of open canopy that meant that they could observe their surroundings a lot easier. They could collect more data effectively, faster than their Russian adversaries. And the plane had hydraulic controls, so they could use that data to orient and then decide and act faster than their Russian counterparts. They could progress through this OODA loop, observe, orient, decide, and act quicker, just a bit quicker than their Russian adversaries. And that was game-changing, because they could just keep outwitting the enemy and win more of those flights, more of those battles. And it's exactly that dynamic that happens with the data flywheel. If you as an organization can implement one of these, a data flywheel around your different AI applications, and you get that running, it's very, very hard for someone to come in and catch up or overtake you at that particular application, especially if you're very careful in your use of the proprietary data that is being output by that process to feed back in and make your AI learning. So hopefully I've sold you on the idea that you should all be building data flywheels. And I've spoken to some of you already today, and I know that a few of you are already doing this. You just might not be calling them data flywheels. Or maybe you are. I'm very keen to speak to you, as many of you as possible, that are interested about this. But it leads to the question, how do I go about building these data flywheels? What practical steps can I take? And I'll say a little bit about this. There's a lot more that I'd like to say, but I've got to keep my talk to time. There are 5 key elements to building data flywheels, and each of these could be subject of a 20-minute or even an hour-long talk. But I'll just touch on them all briefly, and then if you're interested in discussing further, I'm going to be around all day at the Snowplow stand, so please come over to pick up the conversation. Those 5 elements, those 5 key ingredients to data flywheels are proprietary data, real-time architecture, feature pipelines, data quality and governance, and the ability to capture all the decisions, both human and AI, across all the different interactions. So let's dip into each one at a time. So I've talked a lot about proprietary data, and I keep insisting on using the word proprietary because this is really, really important. I can't emphasize this enough. Proprietary data is what fuels the AI application. It's what drives the performance. You can fuel an AI with proprietary information, or the data doesn't need to be proprietary. But if you want to use AI to drive competitive advantage, you have to have proprietary data. It used to be that companies could build advantage in AI by having better models than their competitors. But we live in a world now where we all have access to the best models out there. There are not many organizations, maybe, you can count them on the fingers of one hand, that can build models that compete with the likes of GPT. Just the amount of resources and required and technical expertise is just unimaginable. So we're living in a world where compute is commoditized. We're all, using exactly the same compute as one another. We're all using exactly the same models. The models keep getting better and better. There's a handful of providers of those models. And so the only place left to differentiate in the AI stack is in the data. And this is what sort of Ali Ghodsi, when he was on stage with Jensen Huang, sort of highlighted when he said, people have now realized how valuable their data is. There's no doubt about it. It comes back to what special data do you have that no one else has, and how can we actually monetize that? And that's a question that more and more organizations are asking themselves as they think about how they're going to use AI strategically to compete. The second thing is real-time architectures. If you're playing basketball, if you're you're flying a military plane, having a dogfight, if you're trying to serve the best personalized experience to somebody visiting your website, that ability to take the most recent data, compute on it, and act on it fast is key. Obviously, the consequences of not doing that in those different examples are wildly different. But time to serve predictions and the time to work around that OODA loop to get your model improving based on the data, those are really critical, because obviously the faster you go around that loop, the faster you're able to learn, the harder it is for your competitors to catch up. We started Snowplow in 2012. The data engineering landscape for real-time data processing has just, evolved at an incredible pace in that time. And the tools and technologies for building these real-time systems is getting better and better, sort of day by day and month by month. So this requirement is getting easier and easier to meet. The third thing that's really important is being able to turn that data into features. And you all in the audience will know more about this than I will. It's all great having this mass of unstructured data, but if we're going to act on it fast, we need to be able to turn it into something meaningful that we can use to improve our algorithms as fast as possible. So the particular diagram here is from a particular example application that uses a large language model to create a hyper-personalized email for a customer on a website. And what it does is it looks at all the different emails that have been sent to the customer in the past and categorizes them against these features, a humor, voice, length, social proof, to understand the preferences of the user and the impact of the language in driving a positive response from that customer. And so this is very, very actionable. When you're able to generate these kind of features as fast as possible, you've got the ability to build a learning system. The fourth thing on the list is data quality and governance, and it breaks my heart there's only one slide on this. I'm very happy to talk about data quality and governance for hours and hours and hours. It's critical that, first of all, humans and AIs, because AIs are making more of these decisions than humans, if not already, then in the near future, they have to know what that data means. So understanding the semantics of the data and having the semantics ship with the data is really, really critical. And it drives a huge amount of performance, especially in agentic applications. So semantics matters and trust matters. If you don't trust the data, if you garbage in, garbage out, I don't need to tell any of you that. And it's also critical, if we're taking this data, we're making decisions quickly and then learning on this, we have to know that the use of the data is compliant. So in exactly the same way that the metadata that describes the semantics of the data needs to be packaged and follow that data, the permissions, what you're allowed to do with that data, needs to follow with the data and drive all that data processing. And so the key with data quality and governance, the one thing I'll allow myself time to say, is that these need to be built into the data manufacture process. Data doesn't rain down from clouds. Data doesn't lie around in our organizations. Data has to be actively manufactured. And if we control that manufacture process, if we build that data manufacture so that semantics, quality, and governance are built in, then these things become much, much easier to manage over time. And the last thing that's really important, and this is actually the one that I see most organizations getting wrong, is capturing all the actions and decisions that are made. And that's all the decisions and actions that are made by both the humans and the AIs. So we started Snowplow, more than 12 years ago. And so tracking users across websites and mobile apps, that's old. People have been doing that for ages and ages. But the assumption that we've made up until now is that those websites, those mobile apps, those different digital journeys, the user's navigating some kind of fixed landscape. They can go from one page to another page, but those pages are largely invariant over time. That's not the case today. Those journeys are changing radically because you've got all these different personalization engines that are making decisions and actually changing the experience. And so if we want to understand the customer journey, we've got to understand not just what the customer's deciding to do, but what the AIs that the customer's engaging with directly or indirectly are deciding to do. So in the example here, just to illustrate this point, we have a user on the left that's visiting a website. So in this example, they're on a snowboard shop. And the user views a few snowboards, dwells on them a bit, thinks about it, but then drops off the website. And the idea is that there's an application that's built to try and re-engage the user. So the first thing that happens is that data about the user journey is funneled to a traditional machine learning model that figures out what's the user's propensity to buy, and if they are going to buy, what are the one or two snowboards that they're most likely to buy. That is a decision that needs to be tracked. And then that information is passed to a separate microservice that figures out, okay, well, I know what this user's likely to buy. What's the best email? What's the hyper-personalized email I want to create for just this user to get them back in the store? And that microservice consumes the features that I showed you a couple of slides earlier. And again, we want to track when that hyper-personalized email is composed. What was the email and why was it composed that way? Because we're going to want to analyze that after the fact. And I'll show you what that analysis might look like in a second. Then the email gets sent, and we want to track that this email was sent. We want to track that the user opens the email. And if the user then clicks through in the email and turns up back on the website, we want to track that as well, especially if they make a purchase, because then we know that our email was successful, and we want to feed that back into our different AIs and let them know that the decisions that they made earlier on in that journey were correct. And so, I'm sure many of you are familiar with web tracking, but it's really important that we also track those decisions by AIs. And this is an example of the payload that we generate when the AI has composed that hyper-personalized email. And so you can see some of the data points on the right. The really important ones that I'd call out are we're tracking the full text of the email, because that's ephemeral. If we don't capture that, we might lose that information forever. We're capturing the key facts about the customer that drove that prediction, and then the key facts about the model that made the prediction. And then we can use that data, like we humans can use that data to then analyze, does a particular model do a better job than another at driving the user behavior that we're looking at, or do particular types of users respond better to this? So we can then aggregate that data. But critically, the AI can obviously use that proprietary data to make better predictions going forwards. So this data helps the whole organization measure and learn. And the critical thing is that we're tracking that complete journey. It's not just a user making decisions, it's a user interacting directly and indirectly with a number of different AIs. And we need to understand what the sum total of those interactions is if we're going to optimize that customer journey. So look, building these flywheels is very doable. I know a number of you in the audience are already building these. And I hope that this framework is helpful for you or for others that are thinking about building this in terms of thinking about how they drive competitive advantage. And incredibly impactful. We've seen organizations in retail, we've seen organizations in media go down this journey and very, very quickly develop, go from 1 to 5 algorithms to 10, 50, 100, more than 100. And in the media example, given this is an organization that within a year of starting out on this journey saw really high business impact, increasing subscription rates, registered visitor engagement, and loyalty. Super quickly, I'll just summarize the key points in that journey. They started off with an algorithm to measure the monetary value of the different content items that were posted. The output of that algorithm then helped them come up with a second algorithm that measured the impact of placement. So, news items that were further up on the homepage naturally drove more ad revenue and subscription revenue than further below because more people interacted with that. They could then use that algorithm to optimize the placement of news items through the news cycle to maximize revenue. And over time, that evolved into algorithms to help them figure out should content go behind or in front of a paywall, and set dynamic prices for different subscription offers to subscribers. So it's super, super powerful. But there are a number of different examples that we can talk to. So please do visit us at booth 6 if you find this interesting and helpful and want to discuss further. And in the meantime, thanks so much for listening to me.